Okay, hi Zach, welcome to lesson number 82. Today we're going to be evaluating functions and then looking at domain and range. So open your book to page 337 if you want to follow along. Okay, so here we go. Here's just a fun little cartoon. Look, SpongeBob is sending some love over to Squidward and he chokes on it. Okay, and not all math puns are terrible, just some. So you should like my jokes in this. This is going to be great. Alrighty, let's start with 82A, evaluating functions. All right, so they first talked to us about functions back in lesson 28. We were sort of introduced to the concept of a function. And we learned that a function is like f of x, right? And that's kind of all that we learned. So now we're going to expand upon that idea. So a function of x is a function. It can be considered a function. X can be considered a function if the expression has, this is going to be important, just one value for every value of x, for every value of x. So when you put in an x, the function is going to spit out an output. So I think of functions kind of like a machine. So this is the machine, and it has this equation written on it. So this is the equation that sort of defines this machine. And what you put inside is the x. And what it spits out is the y. And the y that it spits out depends on what type of machine it is, okay? What type of function it is. So for example, if this is the function that we're looking at, f of x equals x squared plus 5, we can put inside the machine the number 1. So what we would do is we would put in, let me make it bright, f of 1. And if you put in f of 1, okay, then that gets put into the machine, and anywhere that there is an x, instead of an x, you're gonna substitute a 1. So here we go. F of 1 equals 1 squared, which is just 1, plus 5. So it's going to be 1 plus 5, so it's going to spit out the number 6. Okay, so that's how the machine works. If you put in a different number, like how about we do f of negative 1. Okay, so now we're going to do f of negative 1. We put that in for the x. It's negative 1 squared plus 5. Well, negative 1 squared is just 1, because it's negative 1 times negative 1. You add 5 to it, and it spits out a 6. And that's okay. Even though it's the same number as before, that part doesn't matter, because I kind of think of it as like a vending machine. And if you want to spit out the number 6 on the other end, that's fine. You can either put in a 1 or you can put in a negative 1, and that's fine. It's just like putting $1 in or putting in 4 quarters. It doesn't matter. You're still going to get a 6 either way. Okay? What if we put in f of 2? Well, then you're buying something different probably. So let's plug that in and see what you are buying. F of 2 is going to be 2 squared plus 5. So it's going to be 4 plus 5, and you're buying a number 9 with that. So that's fine. Okay, and what about the square root 2? You can also do that. If you do that, it's going to be f of square root 2 is equal to square root of 2, that whole thing squared, which is just going to end up being 2 plus 5, and that's going to spit out the number 7. Okay, so you just bought a 7 with that square root 2, which is fine. Okay, so that's how the function works. That's how the little vending machine works. So now we're going to jump into some examples. There are a lot of examples in this lesson. Okay, so let's do 82.1. There's also a lot of GIFs about vending machines. Here's Dwight trying to empty one for some reason. I don't know exactly what he's doing. Have you seen this episode? Let me know if you have, because I don't know what's going on there. But anyway, it says if f of x is equal to this, so that's the machine, find f of 5. So this is easy, because all you do is you're going to plug in that 5 anywhere that you see an x. Okay, so you're going to put in a 5. 5 goes into the machine, and then it's going to be f of 5 is equal to 5 squared plus 5 minus 10. So it's going to be 25 plus 5 minus 10. And you don't need to do anything with this other side. It's just telling you this is what you get with the function of 5. So you don't need to like simplify that or get rid of it. This is not a variable. This is just saying f of 5 is that thing. Okay, so the thing that you get out of the function. So f of 5 is going to be 25 plus 5, which is 30, minus 10. And so the machine is going to spit out a 20. Okay, so you put in a 5, it's going to spit out a 20. And that's what you get. That's what that machine does. Cool. Okay, it doesn't have to be function of x. It could be h of x. That might be the machine. So if that's, here's another vending machine GIF. I don't know what he's doing in this one either. I feel like I have seen that one because he's disrupting this little meeting that's going on there. But anyway, okay, here we go. H of x is equal to, this is the machine now, x squared plus x plus 1. And it wants us to find h of a squared. Okay, now it's just giving you a variable, not exactly a number, which is totally fine. You can still do the problem. It's just whenever there is an x, you're going to plug in this instead. Okay, so here we go. Let's do it. H of a squared. Remember, you don't have to simplify this side. This is just telling you what's coming out of this machine of h. Okay, and so it's going to be a squared, but it's the quantity squared. That's important. Okay, that you get this whole thing that's inside the parentheses a squared in place of that x. Now you have plus a squared plus 1. So let's simplify this, and it's going to be h of a squared is equal to a to the 4th, okay, plus a squared plus 1. And we can't simplify it anymore, so that's just what we get. Okay, all right, let's do another example. Here, poor Homer, I'm pretty sure that's Homer because he's saying, don't. He's trying to put in that old wrinkly dollar in the vending machine, and that never works very well. Okay, example 82.3. We're going to find the function of x if this is our machine, x squared plus 1. Find the function of x plus 2. So this is all in parentheses, so that whole thing that's inside the parentheses is going to have to fit there where the x is, which is fine. We can do that. Okay, here we go. So f of x plus 2, this is just telling you this is what I'm getting out of the vending machine, is x plus 2, the whole quantity squared, plus 1. Now, don't forget what you have to do when you have a binomial inside the parentheses and then the whole thing squared. It's not just x squared plus 2 squared. No, no, no. Foiled again. You have to foil it, right? First, outside, inside, last. So let's do that. So it's going to be, it's basically this, x plus 2 times x plus 2. Okay, and then a plus 1 at the end. So when you multiply that out, you have to do first, okay, and then outside, which is 2x, and then inside, which is another 2x, and then last, which is going to be 4, right? So f of x plus 2, and we don't simplify this side, this is just defining what comes out of the vending machine. It's going to be first, outside, inside, plus last, and then we've got that plus 1 at the end, so don't forget about that. And then instead of writing plus 4 plus 1, I'm just going to change that to plus 5. And that is the final answer. Okay, this is what comes out of that machine. Now, let's go to 82.b, which talks about domain and range. So that's on the next page, on page 338. Now, it says basically in this book and in this whole math series of algebra, we're only using real numbers. So we're not putting in any imaginary numbers or anything like that, right? So we haven't even got to those yet. So just remember, we're only putting in real numbers. And there's 2 rules to not make that vending machine explode, okay? You can't divide by 0. Don't forget, you can't divide by 0. That will make the vending machine explode. And you also can't have a square root of negative numbers. If you have a square root of a negative number, that will make the vending machine explode. What that means is like square root of -4, right? You can't do that. That is just going to make the vending machine go crazy. So as long as you remember these two rules, then any other real number can go into these vending machines. Okay? All right, so what goes in is called the domain. The domain is what goes in. You can also think of it as X. That's kind of another way that I think about it. It's anything that you can put inside the vending machine, inside this machine. Or what can you replace X with? And it can be like any real number. It might be like 1, 2, 3, all the integers, right? It could also be 0. It could also be negative numbers. It could also be ratios like 3/4 or decimals or pi or something like that, right? Any real number can go into the vending machine, and that is the domain. Now, what can you get out of it? What comes out is called the range. And that's the set of all possible outputs. And it depends on what the machine is, right? If the machine is something simple, like f of x is always equal to 3, well, then your range is only going to be 3, because no matter what you put in, you're always buying a 3. Okay? But the range is the set of all possible outputs. And I think of this as what am I going to get for y? If I put in an x, what am I going to get for y? So the range is sort of the y. Okay? The domain of f is the set of acceptable x values. Okay? So it could be anything, square roots. The only thing that it can't be, remember the rules, no dividing by 0, no dividing by 0, and what else? No negative square roots. Okay, so you can't have like a negative in there. And then what's the range? The range is going to be all the y's, and it's the set of resulting y values. Okay, so let's define a function. I'm kind of going back up to that definition of a function that's on page 338. And it says a function is a mapping from one set called the domain. So the domain is what you start with, to another set called the range. So you're putting in a domain into the machine, it's spitting out a range, so that one element of the domain gets one range. Okay, so what that means is like, if I put in a 3, it's always going to give me a y that goes with that 3. But it can't be like two different things, because you don't want to put in like $1 into the vending machine and you could get chips or you could get a candy bar. No, you want to know if you're getting chips or a candy bar. You get one or the other. You don't let the machine choose. You choose, right? So you know what you're buying if you put in a 3 and it's a certain number. So for every x, there's only one y. For every x, there's only one y. Okay, now the range is different. The range, you can have more than one domain. For example, like let's say you want to buy a candy bar and it costs $1. Okay, so the y is a candy bar. All right, what x can you put in? Well, if it costs $1, you could actually put in a dollar bill, or you could put in 4 quarters, or you could put in 10 dimes. The x might be more than one thing. It could be lots of different things, and that's fine as long as you get the candy bar every time. So for every y, you just have to have one value, but it has at least one domain. Like you can't have an x and then nothing, and then a space, and you can't have a space and then a y. But you have to have one value for every y, and you have to have one specific y for every x. I know that's confusing, but we will go through some examples and you'll get it. And if you just kind of think about it like a little vending machine, I know that you'll get them right, okay? All right, here we go. Here's Patrick. He got that, whatever he's eating from the vending machine. I don't know if I've seen that one. Okay, let's do example 82.4. And it says, if f of x is equal to 2x, find the domain and range of the function of f. Okay, so f of x is equal to 2x. So this is the machine. And it wants to know what is the domain and what is the range of this function. So one way to figure that out is to graph this. All right, so if we graph this, f of x is equal to 2x, there's a couple ways that we can graph it. You can do the y equals mx plus b and say, well, this is the slope and b is 0. It crosses the y-intercept at 0. Or you could just plug in some numbers for x and see what you get for y. So let's just do the y equals mx plus b. Okay, and I'm going to use a brighter color so that we can see it. Okay, so b is the y-intercept and it's right in the center, it's 0, right? So it's just right there. And then we're going to do rise over run. And the slope is 2, so it's rise. I go up 2 over 1. Up 2 over 1. So this point is on the line, this point is on the line. Okay, so if this and this is on the line, then my line looks like, let's see if I can do it. Oop. Wait a minute. I want that one. Okay, so I want that on there. Ah, this is hard. Okay, that's pretty good. Because I wanted this dot on the line, like this dot on the, it's kind of, okay, I want this dot on the line and I want this dot on the line. It's kind of on the line. I need to slide it over a little. Okay, so that's my line. So imagine that this goes on forever in either direction. What is the domain? That's the x value. And what is the range? That's the y value. So the domain, what can I put in for x? Well, I could put in anything because if this goes forever this way, x could be 6, x could be 1, x could be 0, x could be a negative number, and it looks like there's always going to be a y associated with it, and it could be half numbers, right? It could be a fraction and I would get some sort of y. I would get a very specific y. So it could be like 3.5 and I would get a y that's right up there. Okay, so the domain is going to be all real numbers. So it's going to be set of all real numbers. Okay. And then same with y. If I can put in anything for x, even like 3,000, I mean, this is like a really steep line, so it would have to go way off the page, but you'd get something, right? If you put in 3,000 for x, you'd get 6,000 for y, okay? So the y is also, the range is going to be all real numbers. All real numbers. Okay, so that's the domain and that's the range for this particular function. Okay, let's do the next one, 82.5. Don't worry, this gets easier. If f of x is equal to 3, find the domain and the range. Okay, so here's my machine. This time I'm not going to draw it out. I'm just going to think of it as a machine. So the domain is, what can you put in? Well, it's f of x is equal to 3. So I can put in, can I put in a 1? Sure. What will I get if I put in a 1? I'll get a 3. Can I put in 1/2? Sure. What will I get? I will get a 3. What if I put in -1? Well, f of x is 3. I'll still get a 3. What if I put in pi? I think you're getting the point. I will get a 3. So the domain is what can I put in? And the answer is going to be, I can put in all real numbers. You can put in anything. And what's the range going to be? Well, I think you've seen that every time I put something in the machine, I get the number 3. So that's the range. The range is 3. That's the only thing that you can buy out of that vending machine is the number 3. Okay? Alrighty, so let's go on to example 82.6. If the graph of a function f is as shown, determine the domain and the range. Okay, so here's the machine. This time, instead of giving you an equation, they're giving you a picture. And it looks like, okay, so it wants to know which x's can you put in for this machine. Well, can I put in a 0? Yeah, I can, because I will get a particular y with that. So if I put in a 0, I will get, for the y, I'm going to get a 0. It'll spit out a 0. Can I put in a -3? Well, that is not on this line. So if I put in a -3, I don't get a 0, I get nothing. The machine doesn't give you anything. So the machine doesn't function past here. So the only things that you can put in to have the machine function is going to be between -2 and 3. Okay, but then you have to look a little bit more closely. This open circle at -2 means that it does not include -2. So I have to change this to, well, let's do this. Let's write it like this. X is greater than -2 but not equal to, and it's less than or equal to 3. Because the 3 is included. In other words, you can put in $3 and it will give you a 4 for y. Okay, so that's the domain. These are the only numbers that you can put in and the machine will give you something. Okay, and then for y, it wants to know, well, what can it give you? What can this machine give you? It cannot give you any negative numbers because there's nothing that will buy you a negative number. But you can buy a number between 0 and 4, right? Because that's all it does on the y-axis. It goes from 0 to 4, and that's inclusive. So the range is going to be y is bigger than 0 and less than 4, and it's inclusive, meaning it includes the 0 and includes the 4. And you have to also, in order to get the problem totally right, you have to be more specific and say it's the range, it includes all real numbers between 0 and 4. So that's the more precise way to write that, because it could be like 0.0003. Could it be that? Yes, it could. So it's not just integers, it's any real number between 0 and 4. And same with the domain. So the more precise answer here is, let me write it more precisely, is x includes all real numbers between -2 and 3, not including -2. And that's how you write it. Okay, sweet. That's like math language right there. Alrighty, let's look at another machine, shall we? Let's see this machine work. 82.7. Find the domain of this function. So the domain is what can you put in. So what can you put in? And usually you can put in any real number, but this one has a square root sign. So we have to be careful that we're not going to square root a negative number, because that's one of the rules and it makes the machine explode. No square roots of negative numbers. And you also can't divide by 0. So if you want to make sure that you are not square rooting a negative number, this has to be bigger than 5, right? Because if it's like 5 minus 5, then you get 0. That is allowed. But if it's anything bigger than 5, So x cannot be greater than 5. It can't be greater than 5. So it has to be, x has to be less than or equal to 5. Makes sense? And it can be any real number. So let's write it more precisely. So x is less than or equal to 5. And it includes all real numbers with that restriction. Okay, so that's the domain. Those are the numbers that you can put in, and then you'll get something out. It didn't ask us for the range, but it could have, right? Okay, let's do the next example. Next example, 82.8. See, we're just using machines here, right and left. This is great. You put something in, you get something out. 82.8. Find the domain of this function. So again, the domain means what can you put in? What can you put into this, this machine? Alrighty, so what can we put in? Well, let's look at the machine. And it's a 1 over, and remember, you can't divide by 0. So it looks to me like as long as you don't divide by 0, it could be anything. Like, could you put in a -1? Sure, 1 over -1. Sure, that'll spit something out of the machine. Can you put in a 3? Sure. Pi, 1 over pi? Sure. You'll get something out of the machine. So it just can't be 0. So the domain is going to be any real number. So let's see. X is going to include any real number except for x cannot be equal to 0. But it could be anything else. Any real number, a fraction, a ratio, a decimal, any real number as long as x is not 0. Okay? And guess what? That's it. That's it for your whole lesson. So now you get to go do your homework. And do you know why cows wear bells? Why do cows wear bells? Because their horns don't work. All right. All righty, Zach. Have a great day. Love ya. Bye.